A new exploratory frontier, an unprecedented challenge to produce oil at ultra-deep water, beneath 6,600 feet of salt. That was the scenario in 2006, when Petrobras made one of the world's largest oil discoveries in recent years. A new province that covers nearly 60,000 square miles with billions of barrels of light oil. The question was, how to produce that wealth? More than 100 million years ago, as the African and South American continents drifted apart, a new, shallow water environment took shape. Carbonates of microbial origin known as microbialites developed there and became what are today known as the pre-salt formations. Precise knowledge about the characteristics of this new kind of reservoir would prove to be a fundamental challenge. Porosity and permeability were essential to understanding the flow of oil and planning the best production strategies. The company relied on its world-renowned ultra-deep water experience in Campos Basin. Working together with its suppliers, Petrobras developed technologies to make pre-salt production viable. The results surpassed expectations. With solid operational safety, 8 years after its discovery, pre-salt production exceeded 730,000 barrels per day. There were several firsts along the way. The deepest offshore production system with CO2 separation and re-injection into the producing reservoir. This technology has already avoided the emission of more than 1 million tons of CO2 into the atmosphere. The first use of the water alternating gas injection method in ultra-deep waters, in this case at a water depth of 7,200 feet. The deepest subsea well drilled using pressurized mud cap drilling from a dynamically positioned rig. The use of this technology avoids a severe loss of circulation where conventional drilling approaches would be unsuccessful. The deepest flexible risers in the world, and the first flexible risers with integrated tensile armor wire monitoring. More than 40 flexible risers are already in operation in ultra-deep water of the Santos Basin, producing fluids with CO2 and hydrogen sulfide contaminants. The deepest steel lazy wave risers, also the first connected to a spread moored FPSO, and the first to combine the use of mechanically lined pipe with metallurgically clad pipe. And finally, the first use of submerged tether buoys to support steel catenary risers, as well as the first lined pipe steel catenary risers installed by the reel lay method. This innovative concept, the buoy supporting riser, allows the use of freestanding steel catenary risers even in severe mid-ocean conditions. The technologies that today are being recognized by OTC are the result of collaboration by a group of very skilled professionals from Petrobras, our business partners, suppliers, and the academic community. We strongly believe these technologies will help the offshore oil industry to meet the growing demand for energy in a profitable and sustainable way.